functions, we have the radical function, we have the logarithm functions. Of course, different kind of function exist. So, but the domain are the values of x such that when you impute them into that very function, that function will be most students have issues with getting to understand the concept of domain and range. And then students always want to figure what are these numbers? What are these numbers that makes up the domain of this function? What are these numbers that make up the range of this very function? And that is why we use that interval, which is the part 1 of the video. So I encourage you to go back and watch that video. Okay, it's right there in my YouTube channel. Okay, so now first of all we need to know what is domain of a function. I'm going to take domain fully in this video. Okay, and of course I'll also tell you next video what range is all about, but possibly I want to go on domain so that we'll be able to understand it, because if you know how to get your domain, getting the range is not a problem. Okay, let's know how to get the domain. Of course, the question is, what is domain? The domain of a function are sets of values of x. They are what? Sets of values of x. That was why we talked about using the use of set notation and interval, using interval in number line. Okay, set of values of x, as in the numbers on the number line. Okay, such that when imputed into a given function, the function will be defined. Any value of x such that once you impute it into a particular function given to you, of course, you know, we have different kind of function. We have the linear function, we have the polynomial functions, we have the radical function, we have the logarithm functions. Of course, different kind of function exist. So, but the domain are the values of x such that when you impute them into that very function, that function will be defined. So we are going to be looking at basically about 4 or 5 different types of functions and how to find their domain. Okay, so the rules are very, very key. So having noted the definition for domain and range, the next is for us to now delve into solving or finding a domain and range for a particular function given to us. And the first function I want to start with is the linear function. The linear function. And the linear function is a function of the form f of x equal to ax plus b, or ax plus c, if you may like. Okay, a function of this form, you can think about function of this form, f of x equals to 2x minus 5. And of course, you know that f of x simply means y equals to what? 2x minus 5. This is a linear function. A function whereby the highest power of x is what? Is 1. Is a linear function. So in this case, you notice that there is no value. There is no value. I mean, within the real number system that I can put here that will make this function undefined. Any value you can think of: 0, minus 1, fraction, square root of numbers, okay, pi values, the e values, and the rest of them. Any number you can think of, so long as it falls along or around the within the number line system, okay, the real number system, then the function will still be what? Defined. Are we there now? So it means that the domain of this function is all real number. So any polynomial functions, any linear functions, okay, yes, I think I can bring up polynomial function into this also. Like I mentioned, the first one, linear function. Okay, this is linear function. I just mentioned here, linear function. Okay, and the second one here is polynomial function. Of course, polynomial functions are functions that in which the highest power of x is more than 1. Example, quadratic functions or equations. Okay, cubic, quartic, pentic, and the rest of them, power 2, power 3, power 4, like that. So the function of this form, y equals to ax raised to power 3, okay, plus bx raised to power 2. Let me just give a number instead of that, so that let's just go straight. Something of this form. Okay, this is a polynomial function. This is also a polynomial function, x squared plus 3x minus what? 5. This is also a polynomial function. So for a polynomial function and linear function, the rules are the same. Like I said, these are the rules we are using. We want to use to find our domain and range. So the rule are the same. So it's just very easy to find the domain and range of this function. And then why students have challenge with understanding this very example is that they always want to see what are these numbers. Except you are asked to list a number, or you are asked to list some of the number, because you cannot exhaust the number. You understand? It's from negative infinity to what? To positive infinity. So I can say that the domain of this function is x, such that x is an element of a real number. Okay, so we have different ways we can represent this. Domain of this function is x, such that x is an element of a real number. That is one way we can do it also. We can also say that the domain, we can just come here and say the domain is simply what? All real number. You can just come here and say just R. Alright? You can, depending on the option given to you. Okay? So another way again you can see this is, you see this way, domain, okay, domain, okay, of the function is equals to they use this pattern minus infinity comma to what? To positive infinity. Are we there? Remember, I've told us in our part 1 of the video where I introduced the pre-calculus aspect of this class that we don't use square bracket for infinity. You don't close infinity. We don't use square bracket. Okay, this is wrong. We don't use this, even though we are saying that infinity, the number up to infinity are included. We don't use this. So this is wrong as a way of representing your interval for infinity. When the number involves infinity, okay, that is, the number still continue. Okay, so this is what we use. Where we use we use normal bracket. Okay, we use normal bracket to represent infinity and not the square bracket. Okay, so there are various ways of representing our answers, and one of them is this, another one is this, and then another one is this. Just know how to interpret those things, and then know what is involved, then be able to get your answer out. So basically, I've been able to explain linear function and polynomial function, that they are the same. The rule of finding domain and range for linear function and polynomial functions are what? They are the same. Okay, all right. The next one again I'm going to work out now is our radical function. Radical function. Now, what are radical functions? Radical functions are functions that have square roots. And of course, you know that you cannot find the square root of a negative number. Okay, that's number one. Number two, the square root of a number cannot be less than 0. Rather, it is greater than or equal to what? 0. For example, I can find the square root of 0, which is what? 0. Okay, so number from 0 to the right of your number line system are what we can find their square root. So any number below 0, you cannot find the square root of that number. Okay, so that's what we have here. So that means that there is restriction in finding the domain and range of that function. So like I said, in finding the domain of the function. So like I said, the domain are set of values of x, such that once that function goes into that once that number goes into that function, the function will be defined. As in, once you plug in the value for x, you replace x with that number, that function will be defined. Okay, or that function will exist, or it will be continuous at that particular point. Don't forget, in my next video, I'll be discussing limit and continuity of a function. When is the function said to be continuous, and when is the function said to be discontinuous, and what are the types of discontinuity? I'll be discussing them in the part 3 of this video. I've already given us the scheme and how the video will be followed. So make sure you turn on the notification bell and subscribe to my YouTube channel, so that you'll be able to get every update as I drop them one after the other. Now, from now till Monday, Tuesday before your exams. Okay, so now for other purpose, you can also come back to check them at any time. Now, the radical function, like I said, are functions that have square roots. So let's start with this. Now, the question is, what are the domain of this function? That means, what are the values of x? What are the values that I can assign to x? Okay, that I can assign to x, so that once I assign it and evaluate it, I press my calculator like what most of you like doing, okay? I press in the calculator and that answer will not give me math error. That answer will not be undefined. What are the values? And there are so many values. There are families of numbers, okay, that can come in here. But what we are looking at for, we want to know what are the rules in doing this. And the rule in finding this, in fact, in doing this is we set the function inside this root to be greater than or equal to 0. Reason being that square root of a number, like I said earlier, cannot be less than 0. You cannot find square root of minus, you cannot say square root of minus 4 is minus 2. No. We cannot find square root of a negative number. Of course, that will give us a complex number. It's a different kind of number entirely. Okay, the last number system, this thing we have, okay, arrangement. Okay, so, but that is the rule. You set the function in the root to be what? Greater than or equal to 0. So that is the rule in doing this. So automatically have x greater than or equal to 0. Are we there? Now when we say x greater than or equal to 0, what does it actually means? Go back to the video of part 1 of this video where I told you about that pre-calculus. That was one of the reasons why I have to bring up that topic, because it will really help you to be a very helpful tool to you in this part 2. So if you have not watched the part 1, please go back and watch that pre-calculus video I made. Okay. Now what does this actually means? There are so many numbers here, but numbers begin from 0 to what? To positive infinity. So I can represent I can see the domain of this function. I can do it in 2 ways. The domain of this function is x such that x is greater than or equal to what? 0. That using the set notation. I can do it that way. Okay. Now if I don't want to put it this way, you can see the option like this. You can see the option like the domain using the bracket format is this. Okay. From 0, okay, to what? Positive infinity. Including 0. Okay, this means including 0. So every positive infinity, positive number are included in this number, in this result. Okay, included in this result. So that's what we have over here. So we see that the domain of these functions are all positive number. Of course, you can try it. If you put -1 here, it will be undefined. Put -2, undefined. Okay, so number from 0 to the right of the number line system, that are the domain of this function. Okay, so I think with this explanation we're able to get that. But if you didn't get it very well, please you can just ask more questions. Now I'm not going to leave this alone. Okay, like this ones I did here, any function that looks in this form are all the domain remain, the answer remain the same for this very case. Okay, the answer remain the same for this very case. Okay, the answer remains the same for this very case. So, but for this very one, I'm going to take another example again. I'll take another example again. Okay, so I believe you are taking down this very part. If not, you can just check the video again and then take that apart. Let me clean the boards to show you another example on that particular function. Okay, now another example is you are given this kind of question and then you are asked to find a domain. How do you get it? You are asked to find a domain. So like I said earlier, we set this, we say x minus 2 is greater than or equal to what? 0. So that x is greater than or equal to what? 2. So number from 2 to infinity are the domain of this function. So I can say the domain of this function, okay, is x such that x is greater than or equal to what? 2. I can also say that the domain, of this function, okay, is equal to square bracket 2 comma positive infinity. Remember, you can see the use of bracket here. Square bracket is used for 2 when a number is inclusive, because they say greater than or equal to. Then positive infinity is used with normal bracket because we cannot close infinity, as I said in the part 1 of my video. Okay, so whichever way they use, just understand the process of doing this, then you'll be able to interpret that very results. Okay, so I'll see take more example again on this. So you can have time to go to the video to see actually what is happening there. It's just very easy. Just know the rule. Just know the rule. You cannot exhaust the number. Now, a case will come where maybe they may want to, let's say they may want to check on you if you actually know the numbers that are going to be included in this system. Okay, let me just add up that. Now you can be able to, now these are one of the options. You might see an option like this. You might see an option like this. Okay, you might see an option like this. Now you cannot go for this. Why? Because minus 2 is not part of the result here. If we put minus 2 here, this function will be undefined. So you can't go for this. Now what if they change here, they put here normal bracket. They put here normal bracket. If they put here normal bracket, it means that minus 2 is not inclusive. Minus 2 is not inclusive. But if minus 2 is not inclusive, don't forget there is minus 1 before minus 2. That means that you are telling me that minus 2 is also included. And 0 is also included, looking at your number line system. You understand? So that is wrong. So you need to know what are these numbers that should go into that very function. And the next thing is for you to now know how to interpret that very function. And that's why I say the part 1 of this video is very, very key. So go back to the part 1 and take more on that area. Okay. So I will take more example again. I'll take more example. Now we have another one again that says y equals to, in this case here we are now having x minus 2, okay, into x plus 4. X minus 2 into x plus 4. Let's see how we can go about this. Now we say let this be s, okay, let this be x minus 2 into x plus 4 greater than or equal to what? 0. Now they say this time this was greater than or equal to 0. Two things are involved here. Okay, for this time this to be greater than or equal to 0, it is either x is either this was this was x minus 2, okay, is less than or equal to 0, or x plus 4 is less than or equal to 0. What does this mean? For this to be greater than 0, it means that is either this was negative and this was negative. That's what the statement means. Is either this was negative and this was negative. Because if you say negative times negative, we are going to get a positive number. Okay, I'll take the second case. Now, if we solve this, let's check. We are going to have x, okay, s less than or equal to what? 2. Then here we are going to solve x. We are going to get x less than or equal to what? 4. So, sorry, less than or equal to minus 4. Less than or equal to minus 4. That's what we are getting here. Okay, so while, okay, that's the first part of the results. Okay, that's the first part of the results. Then the second part of the result is, if we don't say if this and this were not negative, then that means they were all positive, because positive times positive give us positive. So we have x minus 2, that is the second assumption, x minus 2 greater than or equal to 0, or x plus 4 greater than or equal to 0. So we have here x greater than or equal to 2, and then x greater than or equal to minus 4. So you can see, so you see that any of this condition is possible. Alright, so if you check for a number that is less than or equal to minus 4, less than or equal to minus 4, and plug in here, okay, the function will be defined. If you also check for a number that is less than or equal to 2, and plug in here, the function will also be defined. Then if you check for a number that is greater than or equal to 2, okay, and plug in here, the function will be defined. If you also check for a number that is greater than or equal to minus 4, and plug in here, the function will also be defined. Okay, so these are some of the things that we need to look at under our domain and range. But if you still have any challenge, any question, like I said, under this very concept, we can still ask more questions. So let's check for more other rules. Okay, the last rule I'm going to look for is for rational function. I'm going to check for the rule for rational functions. Okay, so you can go through the video, and then if you have any question, please drop it at the comment section. Let the comment section be booming. I want to be getting comment on the comment section. Please drop every question you have. Any question you have, drop it on the comment section. And if there's anything I need to do that is more than that, will now take us to our WhatsApp group. Okay, but for now, drop it at the comment section. Let's look up to the next one. Now the last one I'm going to do here is for rational functions. Rational functions are functions that are in fraction. Functions that are in fraction are called rational functions. They are called rational functions. Okay, so that's number 3 functions to consider. Okay, so rational functions are functions that are in fraction. So of course we know that example of such function is f of x equal to 1 over x. Okay, and for this function, the restriction or the rule in finding the domain of rational function is very simple. We all know that if we divide any number by 0, that number will be undefined, that function will be undefined. If we replace this x with 0, okay, if we assume that x is equal to 0, if we replace it here and we have 1 over 0, we are going to get math error in their calculator, and that means the function is what? Undefined. So what does that actually mean? That is already a guide for us, that for you to find a domain of a rational function, of a function that occur or comes in fractional form, set the denominator to be equal to what? 0. And once you've done that, you solve for the value of x that will make this function undefined. And then how do you state your domain? Your domain will now be all real numbers except those numbers, those solutions you got here. I hope my explanation is very clear. Okay, let me take it again. Now, we all know that the domain, or that a function of this form is undefined when its denominator equal to what? 0. Alright, so for us to find a domain of that function, what we do is that because we are looking at the set of numbers such that once imputed into that function will be defined. So for us to now find the domain of this function, what we do that we are going to now solve for that numbers, meaning solve for the denominator. That answer, that solution you get, okay, the value you get in that denominator are those numbers, or is that number that will make that function undefined. So what we do is that for us to now conclude on the domain, because we are looking at a set of numbers, the set of the values of x that will make the function defined. So what we do that we are going to now eliminate those numbers from a family of real numbers. Very easy. Okay, let's look at this very simple example. I normally start with it because we start from known to the unknown. Now what we do is that we are going to set this to be equal to 0, x equal to what? 0. Because it is when we have 0 here that this function will be undefined. Now, the value of x is what? 0. By default is 0. So now, check it now. If you replace this with 0, the function will be what? Undefined. If you do this, you are going to get undefined, which is wrong. Okay? So what do we do in this case? What we do is that we are going to say the domain of this function, okay, is what? All real number except what? Except 0. So you can see that I'm using a different way now. Okay, I can still say domain of this function, okay, is simply x such that x is an element of a real number, yes, and then x is not equal to what? And x is not equal to what? 0. You can see. So there are various ways of doing that. I can say come here to use my interval notation. I can still say domain of this function is simply, I'll use this 0, then I'll use my infinity. Then I'll now come here too and say union. I'll use the 0. I'll now set my word negative infinity. Is that okay? Okay, I think I can go from the other way around instead of this way. I may need to go from the other way around. Yes, I can go from this way, 0 to positive infinity union negative infinity, comma 0. So if you notice, I'm using normal bracket at the back of 0 because it means that 0 is not included. Then I'm using normal bracket for infinity because that is 0 for unbounded interval. So you cannot close infinity like I always say. While the same thing here also. So there are various ways of putting an answer. Okay. So there's various ways of putting an answer. So you can see the video. You can see it yourself. If you have any question, you can always ask. You can see it yourself. All right. So you can always pause the video to check what I've done and then ask question at the comment section. All right. So I'm going to take another example again of x equals to 2x all over x minus 1 into x plus what plus 2. Alright, our challenge here is with the denominator and not the numerator. So in case you want to find out, yes, it is at the denominator we have restriction. We don't have restriction on the numerator. Where we have restriction is on the denominator. So that's why we work on the denominator always. Okay, it is only when we have 0 here that this function will be undefined. So we are looking for those numbers that will make this function undefined and we'll eliminate them at the end of the day. So I have this now. So I'm going to have this x minus 1 x plus 2 I will equal to what? 0. And once I've done that, I'll now solve my value of x. So x minus 1 is equal to 0 or x plus 2 equal to what? 0. So solve here, you're going to get 1. While solving, you're going to get what? Minus 2. So the domain of these functions are all real numbers except 1 and what? Minus 2. So I can say that the domain of this function is x such that x is an element of a real number, x is not equal to 1, and then x is not equal to what? Minus 2. Okay, that's one of the ways I can use to represent that. So x is an element of a real number such that x is not equal to 1 and x is not equal to minus 2. Alright, so I have this down there. Okay, so you can check the video, you can pause the video, you can replay to also get the whole stuff down. Okay, let me see how I can rush down the video to see how I can meet up with what I want to do. Alright, now that is it. Now if I want to use the set notation formats, I will say that the domain of this function, okay, is given as minus 2 from minus 2, okay, or from negative infinity, comma, minus 2 with normal bracket, union, then from 1, okay, comma, to positive infinity. That's it. So this shows that this is not among and this is not among. So I use it in various ways. So you can see that to find the domain of rational function, simply you do what? You equate that value to 0, solve for the value of x, and then eliminate that value of x you've gotten from a set of real numbers. Then to find the domain of a radical function, which is function with square root, just let the function in the square root to be greater than or equal to 0. Then that full arrangement is simply the set of real numbers. Remember, inequality goes with set of numbers, okay? While the domain of polynomial functions and the linear functions are all real numbers. That one is no restriction, okay? So I'm just working basically on the major functions that is very common in these exams, okay? Of course, there are other functions, but these are the major ones. So if you have any other question, maybe question on other function or anything that you have come across in your past question, please feel free to share. Drop the question on my comment section, and then I'll be able to answer the question for other people to learn also. Thank you, and I wish you the best in calculus. Watch out for the part 2 of this video, for the part 3 of this video, where I'll be going into limit and continuity of functions. And of course, I'll also be going into composition of functions, inverse wave functions, and the rest of them. Thank you.